All right, so welcome to the video on introduction to like terms. In this video, I will be literally just introducing like terms. Now, in order to understand like terms, you obviously have to know what a term is and what components make up a term. Now, it's a very sticky subject because when you're just beginning, typically there's quite a few assumptions that are made about these terms. Because terms in general can actually get extremely complicated. And I will make a few assumptions with regards to explaining these terms and what constitutes a term, how terms are separated, how you can add them and subtract them. And in that case, these like terms are hopefully going to make a little bit more sense to you after watching this video. So what you see here on the screen is basically 14x cubed y, and that is actually a term. And what I would want to talk about before we get into any like terms is, what are these actual terms that we have here? And what do they have? What components do they have? So you'll notice that on the right hand side I've written, there's a coefficient, there's a variable, possibly more than one variable, as you can see here, x and y, and our variables may actually have an exponent on them. So these are the three key things of any term. And for us, so for this example, just so that you can first get a glance of what this particular term is, notice that in this term, there's actually no additions and no subtractions. And that is the key. Because once you start putting additions and subtractions within all of these numbers and variables and so on, then you start breaking up and you have more than one term. So for instance, if I wrote this as 14 plus x cubed y, or if I wrote this as 14, say even minus x cubed, say plus y. Now in this case, as soon as I throw in these additions and subtractions here, I no longer just have one term. I've separated and I've created more than one term. So the number one thing that you should think about is that terms actually do not have any additions or subtractions. Now, these are simple terms because, again, as I said, the topic is sticky. I will also assume that there's no brackets. I'm not grouping things together because if I group things together with brackets, then again, it starts to fall apart a little bit. So I'm going to assume that there are no brackets. We're just dealing with simple terms. And for these simple terms, we have no additions or subtractions. So if I remove this, okay, and I'll come back to my term here. So what are these components of a term? A term will be typically made up of a coefficient. So it is some number that we know. So in this case, the number is 14. The other components of the term may or may not have some variables. So this x and this y, so these are variables. They do not have to have variables. A term can just be a number, for example. Okay, so for instance, just 14 on its own. So if I would write this as simply 14, it would still be a term. It just would be a term with no variables that are unknown. And that's the key here, that these variables are really just unknowns. So they represent something that we don't really know. It might be some kind of an expression or some other number that's coming from somewhere. Okay? Now, these variables also have exponents. So in this case, so we do have exponents. So this, we have an exponent of 3, and this y, although technically you don't see it, the exponent is 1. Now, here is the other thing that I will assume. We will make the assumption that our exponents are positive. Now, if they're not positive, we can make them positive by using the exponent laws. And if you haven't watched, you can watch the exponent laws. So you do have to know those exponent laws to actually work with these terms. So I'll create a link. Okay, so I'll put it up above. Okay, so in case you haven't watched the exponent laws. Now, those are the key features of a term. And what I want you to know is if terms do not have additions or subtractions, you will then notice that really a term constitutes or is made up of basically the multiplication or division even of known or unknown, okay, so numbers, so some number, which is our coefficient, possibly variables, with an exponent. So it's just a multiplication. So really what this term is, it's 14 times x cubed times y to the 1. But we don't write the multiplication signs in there. Now, because we can also have division, then we can, or we could have even written it like this. And this would still be a term. So a term is always just simply multiplications and divisions that we have between these known and unknowns, numbers, variables with exponents. So let's take a look at some possible terms before we start diving in and talking about like terms. So I've written here, basically we have about 6 different types of terms. And what I want to break down here is kind of all the components that make up these terms. So the first one, okay, which is just 3, notice that the coefficient itself, 3, is the actual term. There are no variables at all. There's no exponents or anything, but this is actually a term. So a term can be consisting of just one element, which we typically call a factor. So this factor is just 3. There is nothing else to it. So that's really the simplest type of term that you have, which is really just a number. Now, the second one that we have, that is negative 2x. So in here, now we do have a little bit more complicated of a term, not too much. So this would be our coefficient. We know this, so it's negative 2. And it consists of just one variable, so one unknown. And that unknown is just x. The exponent on it is 1, although we never really write it. So that is a term, and again, so this is just negative 2 multiplied by x. That's what we have there. So those are definitely 2 terms that we have. Now the third one that we have, which is a b cubed. So often when people start, when students are beginning this, they'll say, well, this has no coefficient. It does have a coefficient. The coefficient is 1. So when we don't write a leading number in front, so this would have a coefficient of 1. So our coefficient, so right here, I'm going to just write coefficient in short. So the coefficient is 1. My variables that I have here, so my unknowns, or just my variables, so I have 2. I have the unknown of A, so I don't know what A is, and I don't know what B is. Now B turns out to have an exponent, so an exponent of 3, and A, okay, has an exponent of 1. And notice this is, again, just multiplication. So in this case, it's A multiplied by B cubed. That coefficient in front is hidden. But this is a term, because there's no additions or subtractions anywhere here. Now, the next one that we have, so this one is definitely much more complicated. So I'll take this, I'm going to paste it. Okay, let's blow it up a little bit. And this one is a little bit tricky because what's the coefficient here? You know, this has 7yz or z, and then it's divided by x squared. So with coefficients, you have to be careful here whenever it is and you have some kind of a division, which is a fractional division. So be aware that there are numbers in front both on top. So in this case, our 7, which is right here. Whoops. Okay, I'm going to just leave it. Okay. And then you do have a number there, which is just 1. So the coefficient here really, okay, is 7 over 1, which is just 7. And that's going to play a role for us because if we go down the line, you'll notice and be able to pick off these coefficients a little bit easier. And now we have 3 variables, which is the x at the bottom, the y on top, and then the z or z on top as well in the numerator. They do have exponents, so y has an exponent of 1, z has an exponent of 1, and x has an exponent of 2. So we have this particular term, which is more complicated, and it has both numerator and denominator. But it's not as bad yet. They can get more and more complicated, but in real life, typically, they may not. Okay, so here, so I'm going to remove this and now move over to the next one, which has negative exponents. So I'm going to copy this and I'm going to paste it. Okay, and I'm going to blow it up. And I will change it because notice that in the definition we said we will assume that the exponents are positive. So if the exponents are negative, we can make them positive, right? By using the exponent law, which is the negative exponents. So here I really have 14, and my positive exponent I will leave. So I can change this and rewrite, and this would be x cubed, and this would be z to the 4. So notice that the negative exponents right here will move down to the denominator by using the exponent law for negatives. So now all my exponents are positive. And now I can say, all right, so now my coefficient, so again, on top I have 14. At the bottom it's 1, so my coefficient really is just 14. And then I have y squared all over x cubed z to the 4. And you can think of this as the unknowns, kind of like your body, right? So you have the body of the whole term, and this is really just your coefficient. So that's your leading coefficient. Now we're going to need to know this because when you're talking about like terms, it will turn out that things that are alike have exactly the same body. So that's kind of how I call it. So now the last one that we have here, so we have this one, and now this, I'm going to copy it, paste it. So here all the exponents are positive already, but now I provided this because of the coefficient. Like, what is the coefficient here? So if you're thinking about this, so what we have is our coefficient. So notice on top, I have, so basically there is a negative. Okay, so I have a negative 1. And at the bottom, okay, I have a 2. So if you pull this away, both from the numerator and denominator, so this basically becomes your coefficient. So really this is negative 1 over 2, and your body is AB squared all over C. Now, of course, when you join them together, then really what you get is that, right? So that's what would happen here if you were writing it. But this is your coefficient, and this is kind of your body of that particular term. And notice that all of these are indeed terms. There were no additions or subtractions at all. So be careful. You know, I can make these very complicated and so on, but as soon as you see, so let's say if I would have, okay, so something like this, as soon as you see a negative, that has now separated. And this would have two terms, you know, so this would be a term on its own, because again, terms are just simply multiplication and division of these variables and numbers. And this would be another term that you would have, and it is separated by this subtraction. Now, it could have been an addition, it doesn't really matter. But the point is that these would be separated. And that now brings us to the concept of like terms. So what are these now like terms? Because you don't just deal with one term all the time in math. You have multiple terms, and you may want to simplify them. So you would want to collect the terms that are alike, that are the same. And I'm going to talk about that next. Now we can do the actual like terms. So let's just remember something with regards to these terms. So terms, whenever we write them out, let's say we have a term here. We'll make it a little complicated. So this particular term, and every term, is always separated into two things. The coefficient that leads that term, in this case the coefficient is 3, and then the actual body, which is made up of the variables, the unknowns. So in this case you have x, y, and z or z, and the exponents that are placed on those actual variables. And with that, what makes terms alike or like terms is that they have exactly the same body. So that's what I like to call like terms. So these like terms must have the same, what I call body. And that is made up of variables and then their corresponding exponents that are on them. Let's walk through a few examples so that you can see. Because bodies may look similar, but they may not be the same. The key word here is the same, so they have to be alike. And once we have them alike, then when we start having multiple terms, we can actually collect like terms then. We can add the coefficients or subtract the coefficients together if their bodies are the same. So here is an example of two different terms. Let's say I have, that's one term, and let's say I have another term. Okay, so we have two different terms. So let's break it down again. What are the coefficient and what is the actual body? So here, in this case, my coefficient here is -2, and my body on this is xy squared. On the second one, so on this one's a little bit more tricky because it has a numerator and a denominator. So in the numerator, I just have xy, so the leading number in there, or the coefficient, is 1, and at the bottom I have 2. So my entire coefficient is 1/2, which is coming from the 1 and the 2. And my body is only xy. So remember, your body is only made up of variables and then the corresponding exponents on them. Now, if you look at this, are these two terms alike? Well, are their bodies the same? So clearly, as you can see, their bodies look similar, but they're definitely not the same. We have x, y, but the exponents are not the same on these. So now, because the exponents are not the same, they're not alike. And we wouldn't be able to add or subtract the actual coefficients here with this. Now, if I change the second term, and I made the second term, for instance, something like this, xy squared, and it was over 2, now the actual bodies are the same. So that's what we have there. All right, so that is our first example. Okay, so let's take a look at a few more examples to actually understand what are these like terms and what makes them the same. Now on the screen, so what you see is we have several terms. There's actually 7 of them. Let's first identify, before we start trying to see which terms are alike, let's identify all the coefficients, and then let's identify all the bodies of the actual term to see and compare. So the first one right here, so the coefficient is -2. The second one right here, so the coefficient is 1/3. So again, remember there's a 1 in front. The next one, so here the actual leading number, so the coefficient is 4. Right here it is 11. Okay, so this one right here, so we have a coefficient of 9. This one again, so a little bit more trickier, so 1/4. Don't forget, the 1 is coming from the front. And finally, so here, okay, the coefficient is 3/5. So that's what we have in terms of the coefficients. Now, in order to identify if terms are alike, we need the bodies to be the same. We actually don't care about the coefficient. We want the bodies to be the same. So let's identify all the bodies, okay, on these. So the first one right here, okay, so the body is A. Okay, the second one, so right here, okay, so the body is just A squared. Okay, so now the third one right here, so the body is AB, constitutes of the variables and the exponent. This one, which is the fourth one, which is A squared B. So this one right here is just AB. This one, which is the A/4, so that is just A on its own. And then the last one right here, so we have to be careful. Remember that for terms, make them all positive so that you can actually see, okay, what's happening. So if I make these positive, it's actually A squared, and then the B to the -1, it will go up, and it's going to be B to the 1, which is just B. So those are the actual bodies. Now, if I look at these and I compare, okay, so which ones are alike, then I can identify them pretty quickly. So are there any ones with A? Just A. Remember, the exponent also has to be the same. So actually, so this right here and this right here, so these ones are alike. So they have the same body. So notice A and A. So that's the first ones. Now, what else is the same? So A squared, are there any other A squared? Nope. Okay, so that one does not have anything alike. AB, so yes. So notice AB here and AB here. So these two terms right here and this one right here, so these ones are alike, so we could add them and subtract them if we wanted to. And then the last one that we have is A squared B, and notice, so this one is tricky. Okay, so these ones are actually also alike. this one, and this one. Notice they don't look the same, right? A squared b and then a squared over b negative. But once you turn this, remember this now becomes 3.5 a squared b. And the other one was 11 a squared b. So now they definitely look the same. When you're working with these, you know, there's so many different varieties, and you do have to actually try them to see and understand, okay, which terms are alike and which terms are not alike. All right, so in one of the next future videos, okay, I will be adding, so if you take, these are just monomials because they're just one term. Now there's binomials and then polynomials, okay, so which means two or more. And if you have polynomials which have multiple terms, we can start to simplify them and add and subtract like terms, okay, in order to simplify and make our life a little bit easier, okay, for the algebra. I hope that you found this video useful. I really thought about, okay, how do I convey these like terms? Because conceptualizing them in the beginning is actually not that easy. But here I hope that you can separate and you've learned about the coefficient and then the actual body, which is composed of the variable or variables and then the exponent. We have made a few assumptions, so notice that the exponents are always numbers, right? If you carry on in math, then they'll get more complicated, but for the time being, it's an introduction to terms, and that's what you should kind of take out. Coefficient, understand there are variables, and then the exponents. All right, thank you for watching. Take care. See you in a future video. Bye.